In this project, I will demonstrate how to use UART-A peripheral on FPB RA0E1 board. Open Escape Studio and create a new project by clicking on this file icon, then select New, then select Renesas C++ project, then select Renesas RA project. A new dialog box will appear. You can give name to your project here. After naming your project, click on Next button, then select FPB RA0E1 board from this drop-down menu. Then click on Next. Here select Executable and No Autos option. Then click on Next. Here select Bare Metal Minimal and click on Finish. A new project will be created. Click on Open Perspective button. After that, FSP configuration file will be open. Click on Stack tab, then click on New, then click on Connectivity, then select UART-A stack. You can observe that UART-A stack has some error related to its configuration. If you take your mouse over to UART-A stack, a pop-up will appear which will highlight the error related to UART-A stack. It is giving us the clock error. We can click on Clock tab. In Clock tab, we can enable clock source for UART-A stack. You can select clock source according to your preference from this drop-down menu. You can change your IDE perspective from this button. After that, click on Window, then select Show View, then select Properties. Now click on UART-A stack in Properties window. Now you can adjust the setting related to UART-A stack. Later in the video, I will demonstrate how to use callback function from interrupt service routine. For the time being, I don't need to change anything here. So I will click on generate project content. After that, click on proceed button. Now open hall entry.c file. User application will start from hall entry function. Now I will create a message buffer which will be transferred to my laptop using USB to UART converter. You can take help from developer assistant tab for function code related to UART-A stack. From Developer Assistant tab, drag and drop UART Open API in hallentry.c file. Declare FSP underscore error underscore t variable to check for error related to function call. Use assert function to make sure function call was successful. After that, drag and drop UART-A write function call from Developer Assistant tab in hallentry.c file. Here in write function call, we need to specify the array we want to send and the size of the array. Use the size of function to get the size of the array. Use assert function to make sure UART-write function call was successful. After sending data, create some blocking delay by using RBSP software delay to create delay in the program. I will create a 1000 millisecond delay by using RBSP software delay. After typing some character, you can press space plus control bar to get suggestions related to predefined macros or variable in your project. Now click on your project name, then click on this hammer icon to build your project. After build is successful, now I can test this program. Connect RA board with USB to UART converter according to this connection diagram. You need to have a common ground between these boards. Then connect RX of USB to UART converter with TX of RA board. Now connect TX of USB to UART converter with RX of RA board. Right click on your project name, then select debug as, then select Renesas GDB hardware debugging. Then click on switch button to switch to debug perspective. Now click on this resume button, then again click on this resume button. You can use any serial software terminal to get the data from USB to UART converter. I am using Termite software. Here, as you can observe, every second we are receiving data from RA board. I have made some changes in the program to receive data from UART. You need to allocate a buffer for incoming data. From Developer Assistant tab, drag and drop UART-A read API call in your hallentry.c file. For demonstration, now I will copy data received from UART in UART-A write API call buffer to send back to laptop for demonstration purposes. Now click on your project name, then click on this hammer icon to build your project. Then right click on your project name, then select debug as, then select Renesas GDB hardware debugging. In debug perspective, click on this resume button twice, then again open termite software. For very first time, it log the data we declare in our program. After that, sending array is set to zeros. Now I will send data from laptop using termite software. As you can observe here, received data is being copied in UART-A write buffers and we are receiving those in our terminal. Now I will demonstrate how to use callback function. Click on this stop icon to stop debugging session. Open FSP configuration file, then click on UART-A stack, then open properties, then click on interrupt. Here you can define your callback function. You can give any name to your callback function here. After that, click on Generate Project Content. Open halentry.c file. From Developer Assistant tab, you can drag and drop your callback function in halentry.c file. If you need to study the demo of callback function, you can click on FSP configuration file, then click on this information icon in UART-A stack. This will open FSP documentation in your default browser. From here, I will copy implementation of callback function in halentry.c file. Now I am making some changes according to this project. Declare g underscore receive underscore complete variable in global space. Now in our main program, I will only transfer received data in write buffers when this receive complete variable is set to 1. Now move your memcopy function in condition when receive complete variable is set to 1. After that, reset this variable at the end of while one loop. After that, click on your project name, then click on this hammer icon to build your project. After a successful build, right click on your project name, then select debug as, then select Renesas GDB hardware debugging. In debug perspective, click on this resume button, then again click on this resume button. Now you can use any serial software terminal to receive data from UART. As you can observe here, receive data from UART is not copied in write buffer of UART-A peripheral. For some reason, receive complete variable is not set to 1. Let's debug this program why receive complete variable is not set to 1. After some debugging, I found out that unless we receive 30 bytes we specified in read function, g receive complete variable will not be set to 1. So I have reduced the array size to 18 character which I am receiving from my laptop. You can even use callback function for a single byte or trigger some event when certain number of bytes are received. Now again build and debug your project. As you can observe here, we are receiving data from RA board. As you can observe here, when I send data from my laptop to RA board, G receive complete variable is set to 1 and receive data is copied in write buffer of UART-A peripheral.